Good evening, all.
Good
How are you?
evening. Kapil. Good.
Okay, today we will continue topic on visualization. Today's topic is on topic 3 actually. I've uploaded it in your LMS. I After the end of this topic, actually, I'm supposed to give you some Excel file, but I will cover this visualization first before because there are some contents here that you will use in your uh, task to do using the Excel files. And then after the visualization, we will cover some topic on little bit on dashboard and then on data mining. Yeah, move into data mining. Actually, I need to add on the dashboard later on. Yeah, just give you some topics on dashboard and data mining. Let's see if you can complete our at least cover some little bit on data mining today. We will start with visualization. Yeah. In the meantime, please write your name and matrix number just for record purposes. Yeah. And then there is an error in the, actually, when I set it on the 3rd of October, but I'm not sure why the due date became the 3rd of October. I need to find the way how to adjust it. It's actually supposed to be 5th of November. Yeah, your assignment date is 5th of November. Okay, I will find how to make the changes. Yeah, it's supposed to be on the 5th of November. Okay, the assignment, yeah? Okay, okay, now we will, I'll share the slide. Okay, today we'll cover the topic on visualization. What is data visualization? Uh, Actually, it can also be information visualization. I think by now you would have understand between data and information thing, but yeah, it's a lot of it we do still use data visualization. Okay, there are two ways how to do data visualization. One is using a summary table. You can use a summary table to so that help people visualize the data instead of looking into the raw data. If you can develop a summary and put them in the table, so it's easier for people to visualize and imagine the situation of this data. Like I said, when you talk about descriptive analytics or descriptive statistics, it is about the centrality of the data and how dispersed of the data. So you need to have some visualization to be able to make some assumption or understand or interpret the position of your data. Yeah, so what so by using a summary table, or you can also use chart. Yeah, so you put up charts in several format of chart. You can have scatter chart, line chart, histogram, column chart, pie chart, and so on. So it will help us to interpret, analyze, and learn from the data. So that's what data visualization is about. How do we create a summary table? How do we summarize our data into a table? We can use distribution tables and so on. So we'll go through distribution table later. And then how do you can also put them into chart. So data visualization also help to identify data errors, especially when you have data which are outliers and far from the normal this set of data. And then you can uh, check again whether these are data errors. And then we will be able to reduce the data set to highlight important relationship and trends in the data. So when you can see the trends of certain variables, yeah. When you talk about data, always we need to look into the variables of this data. We learn more into variables later. In descriptive statistics, we don't really concentrate on variable except for last week we discussed about regression where we can see variables. But when we move into other parts later, when you do predictive analytics and you will and then data mining particularly, we will look more into the variables. So, and then data visualization will be able to highlight important relationship and trends the data so that we can determine the relationship between the variables, particular variables to another particular variables. Yeah. Okay. Then start with an overview of some data visualization. So when we look into data visualization, we start with either table or chart. So it comprises of ink, yeah, data and ink. So Edward Tufte described what he termed as data ink ratio, meaning the ratio between data versus the ink, whether you have more data than ink or more ink than data. so so data ink ratio is the measures of proportion between the total amount of ink used in the table or chart, yeah, the data amount of data, yeah, to the ink, data to the ink, to the total amount of ink in the chart, yeah. So whether the data is the ink is used to describe data or ink is used to describe something which is not data. So it is helpful, data ink ratio is helpful to create effective tables and charts for our visualization. Yeah, so we don't have to cluttered tables or too cluttered charts. So make it difficult for us to understand or to interpret the data. So so data ink, the ink is used in the table that is data ink. Okay, data ink is which is the ink that is used in the table that is necessary to convey the meaning of the data, and non-data ink, which is the ink that is used to serve no purposeful doesn't serve any purpose in conveying the data to the audience. So it can be lines or some other borders and so on. Those are non-data ink. Data ink is on the chart or tables, the content in the cells, which is related to convey the meaning of the data to the audience. So I give you some examples. So this is a low data ink ratio, meaning that you have higher ink ratio compared to the data ink ratio. So we have low data ink ratio, more ink than data. You can see the lines here. So many lines here. So I do not know what is the purpose of so many lines here. So it shows a low data ink ratio. Low data ink ratio meaning that you have low data but higher ink compared to this. This is a higher data ink ratio. Yeah, uh, so you remove the grid line so you can see more purposeful. And then this is the way if when you write your thesis later, this is the way you put in. You don't put in something like this. Of course, when you use Excel, it looks like this, but you need to remove the grid lines and it will become like this. Same goes with your chart. You will have something like this. And then when you remove the ink, there is no purpose for the lines there, the horizontal lines there, because you are when you look at chart, it is not meant to have a specific item, specific numbers. So you can just see the fluctuation here. So this is higher data ink ratio, and then this is a lower data ink ratio. Yeah, this is higher data ink ratio, means that there are more data compared to the ink that you put in. So we remove the unnecessary lines and labels there. So you can see here all the numbers here. 1, 2, 3, 4, 5. Yeah. Yeah, you can see all the numbers here instead of this. So you can skip. Can still see the fluctuation. Okay, this is what it means by increasing the data ink ratio. Then when do we use tables? How do we need to put tables? When do we use charts? When do you use tables in our visualization? You will be using dashboard. Do you need that tables in your dashboard? And then do you need tables in your reports? So when do you need to put reports? When do you need to put tables in your reports? So tables is used when the reader need to have specific numerical value when they require your readers. Why your readers? Okay, remember I mentioned to you that you have in general, there might be specific readers that you can relate to, but in general, there are three levels of hierarchical levels in the organization. You have operational level, you have tactical level, and then you have strategic level. Strategic level are top level management. Tactical managers are usually functional leaders, functional head of departments, marketing, so on. And then operational level are the people who get involved day-to-day running of the organization. Okay. When the operational people, they would like to see some specific numerical value because they deal with day-to-day activity. Whereas for functional level, they don't want to see very detailed, but they want to see a general number so that general position of the business, so you can see fluctuations, and also when they want to determine whether their tactics uh, have been successful or not. The top level management, they want to see the whole organization, where are the organization leading towards. So the top level management may not require all the specific detail numerical value. Okay, it's enough to say we make 1.23 million rather than 1,254,000 and then 127 ringgit and 79 cents. So you don't require the specific numerical value. So you don't need to have tables, but you just want to see the fluctuations. So tables will be used if the reader, depending. So you need to know who your readers are, who will be reading your report, who will be using uh, the dashboard. Okay, in the assignment case, you can pick which type of dashboard you want to use, and then who will be the reader or the user or the uh, user of this dashboard. So depends. So you need to know who is the reader. Then do they need the tables, or they don't prefer to have charts? The next reason why you put tables is when you need to have precise comparison. You need to comparison between value, not just relative comparison, but you need to have a precise comparison. Relative comparison, you can compare using charts, but you need to have a precise comparison. So this is 1.234, this is 1.124, for example. So you need to have precise comparison. Otherwise, you can just show chart and you can see, people can see, okay, this chart is above the other chart. It's much more neater, and then the audience anyway doesn't require to have a specific comparison. Or the values being displayed have applying very different unit and have different magnitudes. Yeah, so you can use tables. Yeah, so this is different tables, it is different magnitude, this or different units. So you can use tables. Otherwise, okay, this is example of a table where you have cost, revenue. Okay, or this. Okay, when you see these tables, do you see the fluctuation? 48, 56, 64, 52, 40, 54 fluctuation. Okay, you can see there is a fluctuation increase. And then how much increase from 48 to a cost? And then in terms of revenue, we start with revenue, 64 to 66,000, 67,000. Okay. If you want to see the precise comparison, precise numbers, yes, you look at it. But you don't see the fluctuation. Actually, you don't see the fluctuation. There are situations here where the company is making loss, where the revenue is lower than the cost. Where is the revenue lower than the cost? You need to look in detail, but you cannot see actually. It is easier for you to see here. You can compare the revenue between the cost. You can see from the month one, the company makes larger margin because there is further, the distance between the revenue and cost is higher, and the margin is reducing. In month two, you can see the distance between revenue to cost is lower, and then it's much more lower in month three, very minimal marginal margin made by the company. You can see the revenue is still increased higher than the cost, But you can see between month 3 and month 4, there is a break even. There is a break even here. You can see the break even in the chart, but you cannot see the break even if you look into the table. And there is a break even here. And then you can see the cost start to escalate month 4, and the revenue start to drop. Cost drop. Of course, the cost drop. You can see here the cost drop, but the revenue drop further. And then revenue start to escalate. The cost still increase. And then there is a break even again. And then the cost drop. And then you have a revenue here. Twice break even here. And then you can see for the at least for 1 month, at least close to 2 months, the revenue is lower than the cost. So the company is making loss. And then, okay, you can see this from this chart, but do you see it in your table? So at times, chart gives more information than tables. But of course, tables give more data. But do you need to have precise data? So that goes back here. You only use table if you need to refer to specific numerical value, you need to have precise comparison, or you are displaying a different unit. Otherwise, you can just use chart, which is more informative than tables. Yeah. That's why people use charts anyway. It's more informative compared to table. And then when you combine, when at the same time you want to see some specific numbers, you can add in actually information here. You can have revenue minus cost. You can add in profit. You want to see some profit here, or you can just retain it as this. So this is data. Information is another. Profit is another variable. I think we added. We mentioned earlier. We add another variable. Is derived from revenue minus cost, a derivative variable. Okay, you can combine this chart and tables, so it provides some more meaningful, but actually you can see if you just want to see the fluctuations and then without the precise comparison, precise numbers, specific values, you don't need to have the tables. It's enough to have the chart. Okay. This as well, you can have this table displaying the head count, the cost and revenue. You can convert it into chart, will be more meaningful. So avoid using vertical line in tables, vertical lines, unless they are necessary for clarity. And then horizontal lines are generally used to separate column titles from data values or when indicating that the calculation has taken place. So you have this instead of you have something like this. Remove the vertical line. You don't need the vertical line. Yeah. And then, okay, this is where design A, you have more vertical line and okay, you can see here design A. So you only use horizontal line when there is indicating a calculation has taken place. You look into design D there. When you look into design D, the calculation has taken place where you get the total. That is where, and then all the vertical lines are removed. And then you have horizontal line to do the calculation between cost and revenue. Revenue minus cost, you can get the profit there. So it is useful to have a vertical line there. But here, when you have the cost, revenue, and profit, when you don't have the vertical line, people will not be able to interpret that profit is derived from revenue minus cost. So this is a calculation. So profit is actually a derived variable from revenue minus cost. So, but when you don't have this line, it is not informative enough. But when you have this vertical line, informative, and then you can see all these months, and then it's the same thing. So instead of have cluttered here, too many lines here, or number design A, design B. You cannot even distinguish the total cost. Yeah. Yeah. So you compare different table design, and then the table design D is much more useful to determine more informative to look into revenue and cost, and then you have profit, which is derived from the calculation of revenue minus profit, and then you can see the title there. We have a vertical line here. We have a total. Whereas in C, you can see all vertical lines here, so it doesn't differ from 1, 2, 3, 4, 5, 6, and total. It doesn't, the box is not different. So you can see the box is different here. So this is how you put your tables. Yeah. You need to learn how to put your tables so that your reader doesn't get headache when reading your report. Yeah, so this is another lines, tables. And then you can also use cross tabulation. So we'll learn cross tabulation using pivot table. I think I'll provide some tables there. Cross tabulation. One way to cross tabulation is to do this range, and then you can have this distribution go between quality rating, the meal price. Yeah, so you put a distribution table from 10 to 19, 20 to 29 instead of having this. So how do you do this? I will give you the Excel for this, and then we'll count this formula, and then there is you use the top 5 pivot table, and you will develop this based on the pivot table. You use this. I will provide you the Excel file, and then you use these notes, and then you develop your own, play with it. Yeah, put them into distribution, categorize them into good, very good, and excellent, and then you can develop a pivot table report. Yeah, something like this. This is a pivot table report. Okay, chart. Now we move into chart. Any questions on tables? I think by now you can general overview of the provided general overview of tables and charts, and then we provided some overview of tables. You will learn more when you start doing it. I will give you some Excel file together with the last week's last 2 weeks notes. Yeah, there will be some Excel file. You will use that as well. And then now we move into charts. There are several methods of charts, and then you need to use the suitable chart. I'll give you some notes later for which chart is suitable for which diagram, where you can put them in your dashboard. Yeah, so charts is a visual methods of displaying data. So one of the method is scatter chart. We look into graphical representation between two quantitative variables. Variables are things that you are keen or you are interested in, and then the value that you capture from is called observation. And then scatter chart is to draw the graphical position of the X and Y, two quantitative variable, graphical representation. That's what it means by graphical representation, graphical presentation, because you are measuring X versus Y. Yeah, because when you don't have X versus Y, you cannot draw a chart, a scatter chart. A scatter chart, you need to have what is the x-axis, and then y-axis. Yeah, for example, price versus volume of sales, for example. And then when you increase the price, whether the volume increase also. So you can, this is what we learned in our demand and supply curve. Yeah, so you need to have two quantitative variables to build up a scatter chart. And trend line, you can draw a line between the points in the scatter chart. You can see the approximation between the relationship between the variables, approximation, because it is not specific on the lines, but you can make a curve. Yeah, it can be a curve or it can be a straight line, depends on the regression value. So line chart is a line that connects points in the chart. So you have points and then you connect them. It can be useful for time series and so on. So, okay, this is an example of sample data for this San Francisco electronics store. I think I'll give you this Excel later. And then this is you use Excel to draw the scatter chart. And then when you link the line, you get the line chart. And then this is the two variables. Yeah, when you say two variables, let me see. This is variable one, number of commercials, sales volume. Yeah, number of commercials, which is the X, and sales volume, which is the Y. So between two variables, we measure the two variables relationship between the number of commercials. So you have this versus this. Yeah, so you can see the relationship between this and this. When you draw the line, you will get a line chart. So it measures the relationship between two variables. Okay. Okay, this is a monthly case, monthly sales data of air compressor. I'll give you data as well. So you can draw them into a scatter chart. And then when you link the points of the scatter chart, you get a line chart. You don't need a grid lines here. You don't need a vertical lines here because you just want to see the fluctuations. But when you see the scatter chart, you don't really see the fluctuations. But when you put them into a line chart, you can see the fluctuations of the month. Okay. This is when you do comparison between the north and south. You can put them into a scatter chart, but you draw the same, you put the same uh, format, same pattern, same line. And this is line, this is dotted. For example, you can compare between the south and north, and you can see sometimes, at times, for example, at the end of the year, the sales at the south is increasing compared to the north. And then you can also have spark line. The spark line is a very minimal type of line chart. Just want to see there is no axis. It just display the line for the data. You just want to see there's no relationship between two variables, just one variables, but you want to see then the fluctuations. You just want to see the fluctuations. It's just consume a little space. You can use them in your Excel. And this is how we develop the spark line for Excel. Show you the spark line first. Where is the spark line? No, there's no spark line. Spark line is a very low, simple line at the bottom. This is the spark line. Missed that. Okay. Okay, this is the spark line below. I need to change color. Yeah. So this color is I use spotlight. Okay, this is the spark line. Yeah, this is the spark line. This is another spark line. This is how you create the spark line. So you can see there is an increasing sales in terms of months from November, sales from North, February, North in January, February, and so on. You can see the fluctuation here. And then when you can see also that when the South starts lower and then increase somewhere in July. So there's a peak here and then drop again, 65, 60, and then increase back to 70, 75, and 80. Okay, you can see the fluctuation in spark lines, and then you can see the tables here number. Okay. This is how you use spark line. And then you can also use bar chart. Bar chart is a horizontal chart. Column chart is a vertical chart. Vertical are columns are vertical. Columns are vertical. Bar is horizontal. To display the magnitude of quantitative variables. So bar chart and column chart is useful to make comparison between categorical variables. Categorical variables. Remember we talk about numerical data and so on, but you have to compare categorical variables. What is the number of categorical variables, male, female, so on. So you can compare, for example, categorical variables account managed by Davis, Edwards, and so on. So you can see the bar chart here. You can sort the bar chart, and then you can also add labels to put the number there. Besides that, you can also have pie chart, bubble chart, heat map. Pie chart, and then when there are three variables, you can, instead of pie chart, you can move to bubble chart. And then you can also use heat map. Heat map is two-dimensional. This is the pie chart. I think everybody knows pie chart. This is pie chart. And then this is a bubble chart where they have three variables here. Billionaires per 10 meters, 10 million residents, per capita income, and number of billionaires. So, and there's two dimensions here. One dimension is at the X, one dimension is the Y, and then the third dimension, which is the size of the bubble. Yeah, and then this is a heat map and spark line. You can see the heat map here when they have colors to differentiate the heat, and then you can see the spark line at the end of it, at the row end there, at the column end there. Column end there, you can see the spark lines. Okay, and then you can also have other additional charts for displaying multiple variables. You can have stack column chart, cluster column chart, or bar chart, or you can have scatter chart matrix where you can combine them. So this is a stack column chart. This is comparing the stack column chart, clustered column chart, multiple column chart where you have north and south, where you separate them. But so you don't make comparison, but you can see the fluctuation of north and south. And then where the clustered column, you put side by side. And then when the stack column, you can see the total because you're stacking them. Okay, this is data. This is a scatter chart matrix where you combine all. This is a matrix. You can use pivot table to do the column chart here. And then we move into advanced data visualization, advanced chart. We have parallel coordinate plot. This is where you use for spot and tree map. This is parallel coordinates for baseball data. And then this is tree map. When you look tree map, you're using heat map. Color differentiate the heat and the size. And then you are looking from the top of the tree. Same goes here, tree map. Looking from the top tree, and then the size differentiate to differentiate the volume, the numbers. Then you can use GIS, and then you can combine with heat map. 3D. Okay, now we have covered data visualization, simple. And then, so now how do you put into data dashboard? What is data dashboard? Principles of effective data dashboard. It's like you have a car, and then you have this dashboard on the car, automobile dashboard, where you see the fuel speed, fuel level, current speed, oil pressure. So the data dashboard is a data visualization tools that illustrate multiple metrics. Metrics means measurement. Metrics means measurement. You need to have some measurement. You use it for measurement, and then it will automatically update these metrics. Whenever the new data comes in, the data dashboard will be live and then will be updated from time to time. Okay, what do we put in data dashboard? For the business data dashboard, we usually put in KPI. KPI include the financial position, inventory, customer service metrics, and anything KPI. Yeah, you can put in your dashboard. You can put your KPI, key performance indicator. So, how do you develop your KPI? Develop your KPI based on every department, every unit will have their role, or every person have their role, responsibility, they have their function, and then have this function has to need to have some measurements to measure how they achieve their performance, and then this measurement is the one that we call KPI, key performance indicator, and then we put indicator into a screen so that we can visualize the fluctuation of uh, the value metrics or information that we get. So it provides timely summary information on the KPIs, which is important to the user, and then you should present all this KPI on a single screen so that we can look at a single glance, we can scan through, understand the business current state of operation. Similar like when you look into your dashboard, car dashboard, you can see whether your temperature of your engine, the speed, your RPM, and so on, even the time and so on. Yeah. So the KPI that is displayed in the dashboard should convey meaning related to the decision that the user want to make. Good. Again, you need to know who are you, the user of your dashboard, and then the dashboard need to make decision. So what kind of decision do they use? Do they do? Yeah, and then to do the decision, to make the decision, what kind of data or information do they need? So that kind of information is the one that you need to put up in your dashboard, not something else. So you put up the information, the data that they need, the decision maker need to make use of in their decision making process. And then this data dashboard also need to call attention for something like unusual measures. For example, you can have red flag, or for example, fraud, you can have a red flag of fraud and so on. Yeah, so color can be used to call for attention to specific values to differentiate between the categorical variables. And then, but so not so many colors. Yeah, so you should also restrain the use of colors. Not so many colors, just the relevant colors like um, maybe the traffic light colors of red, green, and amber, for example. So, or you can have find other colors. Even the hospital triage use the same color. They have this green, uh, green section, the yellow or amber section, and then we have this red section. Yeah, so this is the sample of data dashboard. You can see the uh, graphs, yeah, the charts, yeah. Okay. Okay, now we have covered data dashboard. We have covered visualization. Yeah, we have covered the tables. Yeah, visualization, we have covered tables, some information when you need to you use tables, when you use charts, and then how do you put up your tables, and then how do you use your charts. I will also, I think later on I'll put up some next week. Maybe I'll give some format, which table for men, which chart meant for what kind of information that you want to display. Double chart. And then advanced data visualization. And then how do you put them in your data dashboard? Yeah, data dashboard. And then how do they relate to your key performance in KPI, key performance indicator? Now we move into data mining. Okay, any questions so far? Any question? Lenaka, Sondos Zayan. Any question, Nurul? Nurul Ashikin. Everybody okay, yeah?
Prof, okay.
Okay, yeah. So it's actually an easy topic, visualization. But this relates to your assignment, yeah. When you do descriptive analytics, it usually ends at visualization. Okay, now we move into data mining. Data mining is where when you have a lot of data, then you will start to extract information from this data. Actually, it's a misnomer. We don't mine. We call it, the term should be something like knowledge extraction, pattern analysis, knowledge discovery, information harvesting, pattern searching, data dredging, not really data mining. But anyway, we use the term data mining today. So when we have today we have a lot of data mining techniques, increasing the use of data mining techniques in business. It is caused by three major events. One is the amount of data. We have large amount of data, structured data, unstructured data, and then we have this data generated by human, data generated by machine. We have abundant use, abundant size of abundant data. You can even have big data. So we have so many data. Now we want to start to mine this data. And then coming from the relational database management system, RDBMS, we also have the capability of warehousing this data, keeping this data in a repository. So we have data warehouse. And then the computing power also getting up more affordable, and then we are able to analyze this data. So with these three situations, we have large amount of data could be warehoused, and then the processing capability gives us the opportunity to do data mining, yeah, to mine this data, to extract knowledge from this data. Yeah, we have data, information, and knowledge. So we have a lot of recorded values, which we call observation, or values of variables related to a single entity. And then we will start to learn about this data. There are two types of learning. Here written only supervised, unsupervised learning. Two types of learning. One we call it supervised learning. The other one is unsupervised learning. Supervised learning is where you have a target, usually meant for categorization. Yeah, meant for categorization. Is, remember, you have the numerical data, categorical data, so meant for categorization. You can use you can use supervised learning. For those numerical data, then there is no target, you will use unsupervised learning. So we'll go detail later between supervised learning and unsupervised learning. So, okay, now in businesses, there is intense competition in the global scale. So they recognize value in the data sources. And then quality data also getting more and more. We have customer values, we have a lot of data, quality data. We have better ways to now to cleanse the data. We have system to automatically cleanse the data. We have Power BI. So and then we can also consolidate and integrate data repository. All this data from this internet, from ERP, CRM, and so we can combine them into data warehouse. And then data processing capabilities so increase, storage capability is also increase, and then their cost decrease. So we move now, we also have the trend of converting these information sources from papers to digital form. We call it digitalization, eh, digitization or digitalization. So it gives more opportunity to do data mining, possibility of doing data mining. Yeah, so data mining is a process of identifying valid, novel, potential useful, and ultimately understandable pattern of the data stored in structured databases. And this is by Fayad et al. And then it is a process. Data mining is a process. Data mining is non-trivial. delicate item, and then valid, novel, potentially useful, and then it is understandable. So data mining is not just mining, it is much more into extraction knowledge, doing pattern, identifying the pattern of this data, discover knowledge from this data, harvesting information, to pattern between this data, and we call it data dredging. Data dredging, then we go into data mining. So it combines multiple discipline. We have statistics. Yeah, earlier we talked about descriptive statistics. So still we stick with statistics. We have management science and information systems. We have database management system where we build the data warehouse. And then we have information visualization. We have machine learning, pattern recognition, and then we have artificial intelligence. So all in build the knowledge discovery, or we call today data mining. So characteristics of data mining is about, and the objectives of data mining. The source of data for data mining is usually is a consolidated data warehouse, but not always. But sometimes you have several repositories of data, and then you can combine. You can still use it to do data mining. So data mining environment is usually a client server or web-based information system architecture. So client server, we have a client, we have a server, or multiple client, one server, or web-based information system architecture. So the most critical ingredient for data mining is the data. So data can include structured data or unstructured data, combining structured data and also unstructured data. Structured data are those data with specific format and so on. And then when unstructured data or anything else, so we have video, image, text, or articles, books, and so on, voices. So those are unstructured data. Those both can be mined. And then who are the miner? The miner are often the end users. So for business data mining, so the business managers or business people are the users. So this is the people. The technical people may set up some technical aspect of the data, like data warehouse and so on. But the one that will be doing the mining will be the users, will be you all. So you need to have some creative thinking to understand, and then how to use these data mining tools. Yeah. So what does data mining do? Data mining, actually you look into pattern between those data. You can see data, you can see variables, and then you can try to I've given you the data for customers. Yeah, the file is customers in the Excel file. You look back, then you can see the variables, a lot of variables. And then you can see patterns between these variables and then another variable A to variable B and C. You can see the relationship of this variable. If variable A increase, then the variable B increase or decrease, inverse proportion or proportionate. So you can see the relationship patterns. So there are several kinds of patterns. One is called association, prediction, cluster, and sequential. Go detail, association, prediction, cluster, and sequential. In physical class, I go much more detail, but for your online class, I will not be able to go so detailed because your time is very short. Okay, this is the taxonomy for data mining. So what are the data mining tasks? We have prediction, we have association, we have segmentation. For prediction, we have classification, regression, and time series. Time series. All this prediction will be learning. Is the learning type or machine learning type is supervised learning. Supervised learning means that there is a target. Usually, it is meant for classification is categorization. So and then the regression, you can see some relationship of the regression, and then time series. So there are some algorithm, a number of algorithms. So I put there some algorithm there, decision tree, neural network, support vector machine, K nearest neighbor, naive Bayes, genetic algorithm, GA is genetic algorithm. So these are some of the data mining algorithm. Prediction is where if this so happen, so what will be in the future? So this, so we predict. And then classification is where for example, like we have some attributes. Okay, how do you classify things in the water, in the ocean? So you classify based on their attributes. Yeah. Whales is a mammal because it is warm-blooded, or we call it homoeothermic. And then we have there are it gives birth and so on. So these are certain attributes of the whales, and they make them mammals. So not because they live in water, it should be a fish. So, but because they have attributes related to mammals, and then make mammals. So that is what we mean by supervised learning. Why is a bat not a bird instead of mammals? Because they have furs instead of uh, feathers. Yeah. So there are many other things that you can compare. So those are what we call classification, and then it is supervised learning because we have the attributes to define the classes. Compared to another way, we can look at the bottom where we have segmentation. Segmentation, we have clustering. Clustering is similar to classification, but clustering is without classes. So it is unsupervised. Clustering and outlier analysis is unsupervised because there is no cluster. So we have k-means, expected maximization uh, for segmentation. And then association is when you see variables and association between variables A to another variables B or a variable C. One is more commonly used is the market basket. Market basket analysis, looking into what people bring to their, when people bring basket to the market, what do they bring out? What do they buy? Similar things. So similar things that they bought. So we'll go detail later. Link analysis, sequence analysis, these are association. So association and segmentation are unsupervised learning, meaning that there is no target category or target classes, target attributes. That's compared to prediction, which are the supervised learning. Okay, these are machine learning. Yeah, so we'll learn about machine learning today. Just a simple, not really machine learning, but just understand the learning type. Then we move into from this machine learning when you can move towards AI later, but it's not part of this. I used to teach knowledge management where we include AI. And then other data mining patterns include time series forecasting, yeah, sequence, link analysis, visualization. Yeah, and then what is the difference between data mining and statistics? Statistics is just looking into the centrality in or uh, there are two types of statistics, input statistic and descriptive statistics. Descriptive statistics is just looking into the sample or population that you pick the data from. And then where inference statistics is where you infer the population based on the descriptive statistics. But both these statistical methods are looking into understanding of your data, looking into the centrality and dispersion of the data, what is the range of data, and so on. But whereas data mining is look into relationship between this data to identify patterns, so you can see how we can classify the data, how we can build regression, time series, how we can see association from this data, market basket, link analysis of this data, sequence analysis. We can cluster this data, we can do outlier analysis. We are more towards, data mining is more towards understanding patterns of this data compared to the statistics. So they are not the same, but they pick up data mining derived from statistical processes. So there is a relationship between the two. So we talk about data mining applications. Data mining applications can be used in customer relationship management when you need to maximize return on your marketing campaigns. So you can use market basket analysis. In marketing campaign, you can design combo products. You can improve your customer retention. You can have churn analysis, to look into customer retention and maximize your customer value. You can do cross-selling, upselling. You can identify three most valued customers, customer lifetime value, CLV lifetime values. Okay. And then using your customer relationship management. So data mining can be used in your CRM. And then in banks, you can automate the loan process, application process. You can detect fraudulent transaction. In fact, in last trimester's examination was on the not on the physical class, essentially on the fraudulent transaction, detecting fraudulent transaction using data mining application. And then you can also maximize customer value, and you can also optimize cash reserve using forecasting, with forecasting using. And then besides that, retailing and logistic, you can optimize inventory level, you can improve store layout using market basket analysis, and optimize logistics, minimize loss, manufacturing maintenance, and so on. So I will not read through here. You have the notes. Okay, what is the process, data mining process? We'll start with, there are three common standard process, which is the CRISP-DM. This is a European standard where you have cross-industry standard process for data mining. We have SEMA, which is from SAS Incorporated. We have sample, explore, modify, model, and assess. And then we have knowledge discovery in databases. So you are moving from art to understanding the patterns and move to science. It's a systematic way to do. Okay, start with CRISP-DM. CRISP-DM is a cross-industry standard process for data mining. It's an European, developed by European consortium. It begins, there are 6 consecutive phases. The phase 1, 2, 3 assume 85% of the total project time, and then the balance 50% is on model building, testing, evaluation, and deployment. So first, when you want to start with your data mining process, you need to have business understanding, understand of the business process. What do you do? What is the business process? And then from the business process, you look into the data that you capture along the business process. Well, you start with business process anyway, and then you will capture data and you understand what is the data that you use for the business process, and then you will prepare this data. Once you have prepared this data, you will develop a model, you will test this model, evaluate this model, and then you will deploy this model in your data mining processes so that you can see patterns, you can do sequencing, you can do classification, you can do clustering based on that. So we will then use these models for providing the descriptive analytics as well as predictive analytics. You can use it for prediction later. Okay, this is the 6 steps of it is iterative and then highly repetitive experimental data. First, we start with business understanding of the data. And then from the business understanding, you need to understand the data, and then understand the data. We do the preparation of the data. We develop the model, and then we test the model. And then when testing the model and evaluating the model, we tie it up back with the business understanding. Make sure that the model built and that we are tested is in line or synchronized with the business processes. Then only you would deploy. In the middle there is the data warehouse. Yeah, so this is a data mining process. Okay, beside the CRISP-DM, you have this SAS Institute. SAS Institute, we develop this SEMA process. Start with a sample, generate a representative sample of the data, explore, which is doing visualization and basic description of the data, and modify. So select the variables, transform the variables, representations, and then create a model. So use variety of statistical and machine learning models. Just now, we covered just machine learning models, supervised, unsupervised, and so on. And then they will evaluate the model accuracy and usefulness of the model. Then we will use that models. Then go back to sample and so on. Yeah. So this is SEMA process. The other process is called knowledge discovery in databases, where we have sources for raw data. Then we have target data. We select data to become the target data. We clean the data, pre-process data, to have pre-processed data, and then we transform data into a specific data format that's suitable for us and for our analysis. So after we have transformed this data, we will extract the pattern using data mining method models. So, and then we get the internalization to internalization you learn later in SECI model, SECI model, uh, SECI. Okay. 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 This is some data mining process, and then we start with one method. We call it classification. Yeah. Classification is most frequently used data mining method, which is classification, used normally for categorization data, cat- uh, uh, and then it is part of machine learning family, which is employing supervised learning, where we have the attributes, we have predetermined the attributes, and then we learn from past data to classify new data. The output is categorical, which is either nominal or ordinal. And remember, we talked about numerical data, categorical data, and then this categorical data can be nominal data and ordinal data. So that classification is meant to categorize data. Yeah, this is a supervised learning. We have predetermined the attributes. So the assessment method is to measure the accuracy. So the hit rate, measure the accuracy of this classification method, how they develop the model, yeah, using, and then it need to be robust, scalable, and can be interpreted, transparency, and then you can explain this data. So once you have developed this data, you will do the testing. So I'll skip this testing accuracy model first. I'll show this. So estimate methodology, there are several methodologies for the classification. We start with simple split. There is another method, we call it uh, K4 cross validation. And then we have leave out one, bootstrapping, jackknifing, AUC, yeah, area under the ROC curve. So we'll start with simple split. Yeah. Okay, before we go far, everybody understand classification? What classification is? Classification is where you classify items into classes. For example, like we have animals in the ocean, and then we can classify them into fish, mammals, and mollusks, and so on. So it is based on the attributes. That's why we call it uh, supervised learning. So we have predetermined the attribute and then we develop. Okay, in order to do this model, we will set up, we have predetermined attributes, and then we want to find which set for which group of data and fit into which sort of category. Which set of we have a data and then which sort of category, and then we test them. So when we do that, we have pre-processed data. This pre-processed data will break into two. 70% or two-thirds will be used as training data, and then one-third, or about 30%, will be used as testing data. So the training data from this data, based on the classification we will develop, we have this say we set data, we when we set the data, we already have the answer, and then we let the machine learn, and then once the machine learn, you can develop the model. You will develop the model. That is model development. Then once we have developed the model for the classification engine, so we will do the trained classifier will undergo testing assessment, yeah, applying the another 30% set of the data, not the same 70% data, 30% set of the data. And then we do the model assessment. So how do we do the model assessment is by doing the prediction accuracy. So this is the prediction accuracy. Accuracy is measured using what we call the confusion matrix. When you do confusion matrix, we break them into this true or observed class and predicted class. Say the item is supposed to be a fish, but it is not a fish, then it is the observed class is a fish, but uh, you predicted it to be not to be a fish. So that is true positive. You expected it to be a fish, but it is, and then it is a fish. That is true positive. So expected it to be a fish, but actually it is not a fish. It is, for example, dolphin, this one, it is a mammal. So it's a false positive, something like that. Yeah, false positive. You expected it to be a mammal, but it actually is a fish. You think whales is a fish, sharks. Is it a mammal or fish? Okay. You think it is a mammal, but it's actually a fish. So it is false negative or true negative. You expect it to be a non-fish and then it is a non-fish. Something like that. Yeah. So this is where you compare the observed class versus the predicted class. You predict it to be something and then whether it's actually observed to be something and all. So we have the true or an observed class, and then we have predicted class. So this true observed class, we have positive and negative. The predicted class, we have positive and negative. So we have true positive, false negative, and true negative. From this count, we can measure the accuracy. The accuracy is, for example, if you have true positive plus the true negative, you divide by all the rest, you get the accuracy rate. To measure the true positive rate, you compare the true positive divided by the true positive and false negative based on the observed class. Or you want to do true negative rate, you use this true negative divided by this observed class, the negative observed class, false positive plus true negative. Precision is true positive divided by true positive plus false positive, and recall is true positive divided by true positive plus false negative. So this is the confusion matrix. So this is how you measure the accuracy of your classification model. From once you have measured the accuracy model, so you can have a prediction accuracy here. So your model say is 85% accurate or 70% accurate. So the accuracy will improve and improve when you get more and more data to do your data mining. Okay. This is for simple split. Yeah. Besides simple split, you can have more detail. We call it neural network, more smaller attributes. When you do classification, we can break them into attributes, and then these attributes have granularity. So you can read more about artificial neural network, and then data is split into three subsets: training, validation, and testing. So training is 60%, validation 20%, and testing another 20%. But simple split, you just break it into 70% and 30%, and then you develop the model. You test the model, use the scoring. How do you test it? Using the prediction accuracy model, or the what we call it, the confusion matrix. Any question? Okay, can you follow? My we don't we go through. I think you have to read more because they're short of time. Otherwise, if I want to go detail on the whiteboard that I can do in our physical class, we wouldn't have time. And then validation, rotation estimation. Okay, rotation estimation is you break them into a k number of training. You define your own k number. It can be k5, k10. The k-fold depends by you. You decide. If you decide k to be 10, so it's a 10-fold cross validation. If you k to be 5, It is a 5-fold cross validation, 20, 20, but you don't have so much. Getting 5 to 10 is good enough. So what you do is really you break them into the number of folds. So if in this case, it is 10-fold. In the drawing here, it's 10-fold. When you break into 10-fold, you have this 10%, 10% each. So you will test one, and then you move one. Yeah, so uh, so you have a subset, and then you test one, and then you repeat, 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 repeat until you have this cross validation. So this is cross validation. There are other methods which is leave one out, similar to K-fold, but you use K as the number of sample. Bootstrapping, you have random sampling, and then jackknifing, you leave one out or in the area under the ROC curve. I'll cover this later. And then other classification techniques will be decision tree analysis, more suitable for categorization, of course, statistical analysis, neural network, support vector machine, case-based reasoning. Case-based reasoning is where you use previous cases and use the model from the previous cases to try it on the current case, and then if there is the cases differ, you learn from that model and then you pick up that model. Case-based reasoning. Bayesian classifier, you use Bayes theorem. Genetic algorithm, we imitate the chromosome mutation and rough sets. So this is some classification techniques. We'll start with decision tree. Yeah, one decision tree. So beside this, how do you develop this? Okay, decision tree is also called divide and conquer method. So it divide training set into division one by one by one by one, and then until you break it up. So first you will start with creating a root node. So you imagine the decision tree as the tree, but upside down. The root is at the top. The root is at the top. So you break it into model, you split the model. Okay, this is say fraud. This is fraud, this is non-fraud, for example. Or you can say delinquent account, people who don't pay their loans. Okay, you have the data, okay, you break them into smaller category. Okay, these are the people who pay their loan, who doesn't pay their loan. And then who pay their loan, what are the attributes? You break the attributes smaller and smaller and smaller and smaller until you can determine the attributes at the leaf, at their leaf. So you need to select the best splitting attribute at the branch, split the branch until you move, until you can go to the stopping criteria at the leaf. So you will use this model to determine which data, which people that apply loan delinquent accounts, causes delinquent accounts, meaning that their aging can be more than 120 days, for example. So decision tree algorithm differ on what type, what sort of criteria that you use in your splitting, which variable, what are the value, and then stopping criteria. When do you stop building the tree? Pruning, you can generalize them. There are several algorithms, ID3, C4.5, C5, CAD, CHAID, and M5. Then we will not go detail into this algorithm. But you just need to understand there is a decision tree method to do classification. So we have, this is some ensemble model for predictive analytics. So you have, this is decision tree, regression, logistic regression. You can use this neural network ensemble, and then you can use them to do your predictive analytics. Okay, now we have done with classification. Now we move into cluster. Cluster is similar to classification. One thing, cluster is called unsupervised learning. Why is it unsupervised learning? Because it is still part of machine learning, but there is no target, there is no classes, there is no attributes that we have to compare and predetermine whether this data falls into which set of classes. So it is automatic identification. It is not based on a targeted classification like classes. Yeah, so it is just clustering. So we learn the cluster of things from past data. Now we then assign new instances. So there is no target variable. Yeah? So some in marketing, we call it segmentation. Yeah, cluster analysis. So how do we cluster? It can be used to identify natural grouping of customers. Sometimes we call it customer segmentation. We can identify rules to assigning new classes to classes for targeting diagnostic purposes. We can provide categorization, characterization, definition, or labeling of population. We can decrease the size and complexity. And then you can also use them to identify outliers in the specific domain. Yeah. Some methods into clustering analysis, you can have k-means, you can record k-most, you can use neural network, fuzzy logic, and a genetic algorithm to do cluster analysis. So goal of clustering is to segment the observation of this data in similar group based on observed variable. So you can put them into axes of X and Y based on your selected variables. And then you can cluster them, group them into their similarity, to their similarity. Yeah, so it can be employed during data preparation to identify the variables observation, then you aggregate them. So it's commonly used in marketing to divide customers into different homogeneous groups. We call it market segmentation. Also, we can also use it for to identify outliers. Yeah. There are two methods of clustering. Clustering, we can do bottom up, yeah, using dendron, can cluster up, or you can from the top down, you can do k-means. Bottom up, k-means, or bottom up, top down, which is k-means, or bottom up, hierarchical clustering. So from hierarchical clustering, you look at the bottom, and then you group them, and then you cluster them. K means you determine which number of cluster, and then you break them into similarity based on their similarity. Okay, now you look into how do you do. Okay, from the hierarchical where you look into the bottom up, you will look into similarity, and then how do you determine the similarity based on the tables, based on the graph, the chart. You can see X and Y, you can see the variables, you can see the distance between the variables. You determine what is similarity and dissimilarity between the variables to another, to this point or data to another data. We call them Euclidean distance. And then we draw them, and then we measure the distance, and we need to determine how far distance that we want to pick up to group them into a cluster. Okay, the Euclidean distance is similar, the calculation is similar like you use your Pythagoras theorem. Remember Pythagoras theorem, we did that. So, but anyway, this is the formula for Euclidean distance. If it is just two numbers, it will be similar like the Pythagoras theorem. Yeah, Euclidean distance becomes smaller when the pair observation become more similar with respect to their variable values. So this is what we call the Euclidean distance. So Euclidean distance is influenced by the scale of the variables. So, okay, the standard. Okay, and then I will not go through. Then, in order to measure the categories. We can encode them into what do you call it, matching coefficient between 0 and 1, cluster analysis or jacket coefficient. How do you develop your cluster analysis? By clustering, your hierarchical clustering. There are several methods. One is single linkage, complete linkage, group average linkage, median linkage, and centroid linkage. So I will not go through detail, but I just show you the detail. You can read here, but I should show you in the diagram here. Okay, when single linkage, you can see here, single linkage between 3 and 4. This is one cluster to another cluster. You can see the distance by single linkage. Complete linkage, you can see the furthest number 1 to the furthest number 6 here is complete linkage. At group average linkage, you can combine and then divide by the number average linkage, or centroid linkage will be the center. There are, but beside that, you can also use dendrogram. Using matching coefficient, you develop dendrogram. Yeah. Another method is what we call it k-means clustering, where you do from the top to down. You determine how many cluster that you want to group. Okay, you can have k-means, means you can say 5, it will be 5. It's 3 and then 3. You develop the cluster. Then determine the centroid, the central of the data. And then you measure the observation and then you determine. So you determine first, you need to determine how many cluster that you want. That is the k, number of k. Generate the k random point as initial cluster, each point to the nearest, assign each point to the nearest cluster. So how do you do this? This by using this example here. You can see step 1, you determine this cluster here. Okay, this is cluster 1, 2, 3, 4, 5. And then you measure the distance from 1, you can measure the distance here, 2, 3, 4, 5. Yeah, based on the centroid. Centroid becomes the middle number. And then so we have the cluster here. Step number 3. 4 cluster, 5 cluster here. The furthest cluster is here. 1 cluster, 2 cluster, 3 cluster, 4 cluster, and 5 cluster. This is k-means clustering. You determine the number of k. So this is another method. This is k is 3. So you set the number of cluster. This is 1 cluster. 2 cluster, second cluster, third cluster. From the first cluster, you measure the distance and then you cover this distance. Second cluster, third cluster. So this is the centroid. You put the centroid now, the random. Yeah. So comparing the hierarchical clustering and the k-means clustering. So hierarchical clustering where you have a small data set and then you want to easily examine the solution, increasing number of cluster, convenient method because you want to observe how clusters are nested. K-means is where you have, you know how many clusters that you want. You have predetermined how many clusters that you want. Then you have large data sets, maybe more than 500 observations. So you partition the observation according to the distance. Depends. And this depends on situation. I think I'll skip the association. We don't have time to do association market basket analysis. Okay, we have done today data mining. Data mining, what is data mining? We've done today data mining. Yeah, and then definition of data mining, the ingredients of data mining, the objectives of data mining, the taxonomy of data mining, comparing data mining versus statistics and the application of data mining in businesses. And then processes of data mining. I provided you 3 processes of data mining in general: TRIZ, PM, SEMA, and KDD. And then some data mining methods. We started with classification. And then how do you test your classification? Test your model for your classification. And then the development of the classes model using simple split, where you test at the end. You test your model at the end. You can also have K-fold cross-validation are the method of classification techniques. We did decision tree. And then how do you ensemble models for the predictive analytics that we use in predictive analytics. So we have decision tree, we have regression, neural network, and logistic regression. We assemble them so we can use them in predictive analytics. And then we covered cluster analysis. Unlike the classification where they have a target, cluster analysis don't have a target, don't have a target variable. This is used in grouping of customers. We call it segmentation, customer segment. Some methods, statistical methods. And then how do you do this cluster analysis? Bottom up or K-means. Bottom up, we use the distance. We use Euclidean distance, which is similar. The calculation is similar, like the Pythagoras theorem, which you learned in school. And then hierarchical clustering. You look into the distance between the clusters. K-means clustering, where you predetermine the number of K that you want to use. Determine the centroid, and then you cover based on the distance that you have targeted. Comparing the hierarchical clustering and K-means clustering. So next week we will do association. We will do text mining. And okay, we'll cover this next week. And then we'll move into the next topic, which is into predictive analytics. We will start with some probability. Next we will cover some probability. Okay, and in the meantime, I will upload some Excel file later after this. Okay, any question? We have 3 more minutes before 9:30. 3 more minutes for question Q&A. Haziq, okay, Haziq? Sondos, anything to, yes?
So far, okay, pa.
Yeah, I want to ask about the presentation, Prof. As we have a presentation, right, for the group
Yes.
assignment.
Yes,
So which date exactly will be the group presentation?
second last class.
Ah, okay, thank you.
Oh, no. We'll make it the last class. The last class. The second last class is the date that you need to submit. The last class, the final class.
Okay, thank you, Prof.
Okay. Okay. Otherwise, it's now 9:28. So I think there is nothing from you. Okay. We meet again I think next week. We'll meet again next week. We have 3 weeks, right? This week, next week, and the other week, 3 weeks. Then we'll break. So next week we'll cover some probability. We go back to what we learned in school, probability, and then we move into predictive analytics. Okay. Any question? Nothing? Anything? Okay. See you and thank you very much and Assalamualaikum.
Thank you.
Alaikum assalam. Thank you, Prof.
Thank you.
Thank you, bro.